I have created four different files, four different collab files, two files for training and two files for live production. Okay, so this one is first one, which is basically multi-class classification training. Okay, so in this first I'm downloading the dataset, the same dataset which you have provided. Okay, and then we are importing some libraries which we required, like NumPy for matrix calculation, pandas for database dataset operation for analysis and all, and sklearn for machine learning purpose, and matplotlib and cborn is for graph purpose. Okay, and then we are reading the dataset, we are loading the dataset into pandas frame, converting into data frame. Okay, and then we are printing some random values. So as you can see, after observation, so there is a ID column which have no use. Okay, so it's just ID. Similarly, there are certain columns which having label data and few having numbers data. Okay, and also there are two labels. One is attack category, second one is label. So label is for binary classification. Attack category is for multi-class classification. Correct. Similarly, data. This is the data set information which having 82,000 record, and it is not null, it is pure data. Okay, so what we are doing, then we are printing some description of data set, some doing some analysis. So these are the total list of columns are there. Okay, so then we are dropping up the label column, as this is for multi-class classification, so we no need of label. Okay, so and similarly we are dropping id column as well, as it is no use. Okay, and then I have created a function to plot the bar graph of respected any column. Okay, so this is a function which I have created to plot a graph. Okay, for bar graph. Similarly, here I am plotting the graph for all column. Okay, just like we have a service column which having this number of categories, and it having this number of records. So it is like DNS attack having certain 25,000 values. It is like that. Okay. So similarly, we have plotted a graph for all column with the number of count with the uniqueness. Okay. Similarly, we have this one too. So for the attack category, we have normal, generic, expo, etc. Okay, all this type of attack, and we are plotting the particular uh, graph with respect to values. Okay, so this way we are plotting and doing some analysis. Similarly, here are some more graphs with respect to the same. Here are some pie chart key, how many percentage of category labels are there. Okay, similarly this one as well. Okay, and we have certain this number of records are there. Okay, after dropping up null values and everything, and replacing duplicate values, as we no need of duplicate values, and then we are doing label encoding is something key in our dataset having a three piece label. Okay, value of particular column and some certain label data. Okay, so algorithm not required a label data, it required numbers, right? So we are assigning numbers to that particular label in ascending format. Okay, so that is called label mapping or label encoding, and then we are saving the label encoding. Okay, so as you can see, after label encoding, all data set will be having numbers data only. Okay, and then we are printing correlation of our data set. So this is the correlation matrix, and then we are dividing dataset x and y. So in y we are storing the outputs, the whatever outputs we want to predict, and in the x we are storing all the columns, whatever input columns are there, expect label. Okay, and then we are running a random forest algorithm. So this is the algorithm which I have used for the feature selection. So with this random forest, I am training the algorithm, and then we are I'm selecting top 20 feature to get more accuracy or more accurate result. I have done this feature selection and identified the top 20 features. Okay, and this is the graph for the top 20 feature with the particular uh, equ- the particular priority, or you can say key importance of that column. So highest important column is this one, okay, which are having almost 0.08 correlation. Similarly, these are the all columns value, or you can say importance in our prediction. So here are the top 20 columns are there. So these are the top 20 columns, okay. And now if we go down, then we are again doing the same key with the top 20 columns. We are dividing data into x and y, okay. So here we are basically divided the data x and y with all columns, okay. Here we are dividing data with only selected columns, okay. And then we are dividing data into training, into end testing. We are keeping testing data as 20% and training data as 80%, okay. And then we are saving those file. And then I have created a function. This is a matrix function, which is basically take the algorithm and testing and training data, and it calculate the accuracy, FN score, precision, recall, accuracy. It calculate everything. It is created by me only. So the first algorithm which we have used, that is decision tree. Okay. So first algorithm for training we have used decision tree, and for the decision tree we have got very medium accuracy around 77%. Okay. Similarly, then we have used random forest, and for the random forest we have got 87% accuracy, not much. Okay. Then we have got then the KNN. Then for KNN we have got 77%. Okay, but these accuracies are less, right? So as you have also suggested to add the ensemble model, okay. So then I have added hybrid model, which is ensemble model. There I have combined all the algorithms which we have used, and when I have trained this model, there we got the 90% accuracy on multi-class classification, which is very good accuracy, okay. And then I am exporting certain columns, certain data from dataset with the all classes and random mix. Okay, for the live prediction purpose. Okay, because in live prediction you can't put all values manually, right? So I have already exported these classes. So in the live prediction you can use this for that showing purpose. Okay, so this way we have trained the model. Okay, for training multi-class classification. Similarly, we have created live prediction collab for the multi-class classification. So it automatically download this uh, model file level encoder. Okay, I already uploaded on the Google Drive, and then it will download from there. Okay, so this is the code which I have created, which basically load the model and pickle file, okay, and display the prediction, or ask user to select whether to go for CSV and manual prediction. I have given the both option, whether if you want to showcase with the CSV based prediction, so you can also do the same. If you want to go with manual prediction, you can also do the same. It will both work, okay. And so you just have to run this particular class. You no need to run this training class again and again, because I have already trained the model. You can run this particular live diction code one by one, and then it will ask you input like this. It first ask you whether you want to go for manual or CSV. Then you have to provide the value. If you provide the value CSV, then it will ask you CSV file, and then it will make the prediction. Just like let me show you now. See, now let me restart it. Okay, so it is asking me to whether go for manual or CSV. Okay, so I want to go with CSV. So here you can upload the CSV file which I have shared. So this is why which I have shared, randomly generated the data set. Just like we have this data set which having class 4, the class 4 label, all data are related to class 4. Okay, similarly we have this one which is random mix. It has all classes. Okay, so let me choose this one. So as you can see, I have uploaded and it is making prediction. Okay, so for zero index row we have got the prediction 3, and which is the explolite or something. Okay, similarly if I open that particular data set file, which was this one. Okay, so this is the zero index. Okay, for the zero index, yeah, this one was there. Yeah. So these are the rows which respect to prediction we have got. Okay, so it is like that. Okay, similarly we have done for binary classification. Both the code are same for the training and live prediction. Just the only thing is in the binary classification, we have dropped the attack category, okay, because in binary we have not used of attack category, okay, because if we use that particular column, that means algorithm will give 100% accuracy, and which is basically wrong accuracy, because if already you are telling algorithm ki which type of category it is, so obviously algorithm will make the label a binary classification very easily, okay, so that's why I have dropped it to get algorithm more complicated, okay. Similarly, we have dropped ID column. Just the only thing is we have dropped attack category, and instead of attack category, we have used label as output. Okay, zero is like key normal, one is like key attack. Okay, so rest code are same and everything is same. Just the thing is accuracy difference. Okay, so in the binary classification, we have got very good accuracy. For decision tree, we have got 90%, and for random forest we have got 96%, okay. For the knn we have got 87%, and for the ensemble model we have got around 96, which is very good accuracy, okay. Similarly, binary live prediction code is there, so you just need to run this, okay, and you can upload the file. I will share this folder as well. So I have split it like this, okay. Binary classification sample dataset you can upload from here, and multi classification dataset you can upload it from here, okay. So this way we have completed your system, okay. And do let me know in case anything is required, okay.
Thank you, friend, for watching my video. If you are new, then subscribe channel and share with a friend. Thank you.